Okay, let's start. Welcome everyone. I'm Shantanu, Chairperson of Robotics and Automation Society at VPIEEE. Welcome to this workshop. Today you will be learning how to make your own document scanner. So before that, I will just give a overview of computer vision. Okay, I hope my screen is visible. Yeah. Okay, so what is computer vision? Computer vision is essentially a subset of artificial intelligence. And the goal of computer vision is to make sense of images or to obtain meaningful data from images, videos, etc. Basically, to uh, extract information from whatever the visual input is. Okay, so when I say meaningful data, what do I mean by that? So, meaningful data is like consider this image here. So, if a human is looking at it, for example, like you just look at this image, you will immediately tell like this there is a car over here, or this is a person over here, this is a traffic light. Okay, so these all are like some data that you have extracted from this image using your own vision system. Okay, so like other examples like an object's position or detecting an object or detecting shape or colors. These all are like uh, data that can be extracted from images. Okay, moving on. So let me give you a brief history of computer vision. Like some people think that computer vision is new, but actually it's not. It's not very new. It kind of dates back to early 1970s. So like it started in like late 1960s or early 1970s. So the researchers were aiming to mimic human vision system. Okay, they were like planning to create a system that can actually work like our eyes do. So initially, like some researchers thought that this would be a very easy task, like just show a picture of a cat to a computer and it will detect that it's a cat. But actually, like as they did more research, it turned out that it is a very difficult task to make something similar to human vision system. So, like part of the reason why some people thought that it would be easy is because our own biological human vision system is so advanced that, like, to identify an animal or an object is like takes like no effort. Okay, but to computer, an image is just a collection of numbers. It doesn't make quite sense to a computer. So like that's the main reason why computer vision is so difficult. So in this image, like you can see, this is a main like brief timeline of how the research went in the field of computer vision. Like it started as a basic digital image processing in 1970s, and then like it further progressed, and now like we are in the learning stage, like deep learning and machine learning. In 2000s, the fields of machine learning and deep learning have helped so much that computer vision is like growing at a faster rate, like seen never before. Yeah, so moving on to some applications of computer vision. Like there are several applications like photography, augmented reality, medical applications, etc. But like the one application that we are most interested in is the application in robotics. Okay, so we know like robots are made to mimic human actions. So it would make perfect sense that on one hand robot mimic humans, and on other hand computer vision mimics human vision system. So like it makes sense to combine those two things and just make like a robot with a vision, because as robots are becoming more advanced and are becoming more important in our lives, so we need the robots to also have a sense of perception of what's happening around them to better help us. Okay, so we need some kind of a vision system so that the robots can interpret their world around them and can like navigate through some paths, etc. So like the computer vision and robotics integration is very important and has resulted in some very awesome applications like a self-driving car, or like in the you can see in the picture, or our industrial autonomous robot, or even autonomous delivery drones, and several other applications. So yeah, that was some basic idea about computer vision and why it's important. So like in computer vision, we are dealing with images all the time. Okay, without any image or videos, and the computer vision makes no sense. Okay, so it's important to understand what are images itself. So images are like a collection of pixels arranged in a array. Like you must have studied in mathematics. Like there's a topic called matrices, where numbers are arranged in rows and columns. So that's what images are. The pixel values are arranged in rows and columns. Okay, and the whole image just represents the visual information. Like for example, here we can see the picture of Abraham Lincoln. So if you like zoom in, if you keep zooming in, you can observe these small squares. Okay, these squares are nothing but pixels, and these contain some numeric value. So pixels are basically building blocks of images. Like in the real world, we study that atoms are the building blocks of all the matter around us. The pixels are the smallest building blocks that we can interact with, that can be processed. Okay, so each pixel contains certain value, and when all these pixels are arranged, they make a whole image. Is in this figure below, like this is a colored image. So there are in each pixel there are three elements. First is like these three elements are called subpixels. So there's a red subpixel, blue subpixel, and a green subpixel. These three elements combine to make a single colored or a single RGB pixel. So like you may not know what is an RGB. Like there are different types of images, not just colored ones. There are different types. Let's talk about types of images. So there are basically three broad categories. First one is binary, then colored, then grayscale. So binary is like nothing but like as the word suggests, it contains it can take the pixels can take two values, 0 or 1. 0 means black and 1 means white. So imagine like pixel is a bulb. So when it's 0, the bulb is off, and when it's 1, the bulb is glowing. So that's binary image. Then there is colored images. So colored images are a bit complex. They are divided into three parts: red, green, and blue, like RGB. Okay, so like the all the pixel values of red, green, and blue combine to make a colored image. Colored image can all be like further divided into according to the bit size, like 8-bit, 10-bit, 16-bit, and 24-bit, etc. Like 8-bit is like most common image format. So what 8-bit means is he like bit what's bit? It can take two values, 0 or 1. Okay, so the total amount of combinations that you can make out of it is 2 raised to power 8. That's 256. So the pixel values can range from 0 to 255. 0 being that the pixel is off. So they are like 256 red values, 256 green values, and 256 blue values. So that's about 16 million color combinations. So like 10-bit is you can like calculate how many uh, color variations can be possible in 10-bit. Similarly in 16, 24, and so on. In gray is basically different values of or different shades of gray. Okay, so 0 means like it's black, and one means that it's white. Similarly to in colored images, uh, grayscale images are also like 8-bit or 10-bit, depending on the bit. So in 8-bit grayscale images, there are two, 256 shades of gray. Okay. Similarly, in 10-bit, there are like in 10-bit images, there are like 2 raised to about 10 shades of gray. Okay. So these are like the different kind of broad categories of images. Moving on to image channels. So like image, you might think like that an image is a 2D array, but in like a colored image is kind of a 3D array. They are like three 2D arrays stitched together. So they're like one array for red color, one array for blue, and one for green, and they are like stitched to form a colored image. So these three red, green, blue are called channels. So a 3D image is basically three-dimensional mathematically. Similarly, grayscale images are only two-dimensional because they have only one channel. Yeah, so that was about image channels. So yeah, so like we discussed before, to get most out of your images, we need to somehow manipulate these images. Okay, because the raw images don't provide us with much information. So there are several tools. Like today, we will be showing you how to manipulate images using OpenCV. So OpenCV was like most famous library initially developed by Intel and for internal purposes, but then they open sourced it. Like everyone can use it; it's for free, and you can like perform some cool stuff like edge detection, feature extraction, or thresholding. Okay, so yeah, before we move to the code part, these are some installations that you might need. Uh, like it will work for any IDE, but we prefer PyCharm because it's easier to install stuff on PyCharm. Then you will be needing Python, of course. Then there's a package called NumPy, which is like default for array. All array related operations are done using this NumPy. And then lastly, the OpenCV itself. Okay, so let's get to the code. 1 second. Is my screen visible? Can somebody type yes in the chat? Okay. Okay, so before moving further, I will just show you some basics of OpenCV to get you started. Okay. First, we'll import the libraries that we'll be needing. We'll be needing these two libraries. This is OpenCV and this is NumPy. If you want to install, I'm using PyCharm. If you want to install libraries, go to settings, then your folder name, then interpreter, and then click on this plus icon, and then just search for the package. I've installed this already. Okay. Install this one. Okay, so first of all, we will learn how to read an image. So first declare a variable called image name. So I have a test image here. This is the image. Okay, so file name is test underscore image dot jpeg. Okay, so yeah. So there is a function called cv2 dot imread, image read. Okay. Oops. So you input the file name. It converts this to a array. Okay. So let me print image. So this is the image, all the values. These values are between 0 and 255. Okay. Let's see the dimensions of this image. So this is a NumPy array. Okay. You can check the type. Okay, this belongs to class NumPy array. You can also check the dimensions of the image by image.shape. This is in OpenCV, the convention is height, then width, and then the number of channels. So this is the height, this is the width, and this is the number of channels. So 3 channels RGB. Okay. Let's display this image first. So you can do this by a function called imshow. It will generate a window. So you have to name the window. I'm naming it image. You can name it anything. And then you have to pass the array. Pass this image. Okay. So now see what will happen. So it showed and then it closed immediately. So I have to put some delay to it that it stays there. So if you write 0 here, then it will continuously show the image until you press any key. Or you can it takes arguments in milliseconds. So if you want to display the image for 5 seconds, then you can write 5,000 milliseconds. Okay. So I am writing 0 because I can press any key and then it will close the window. Okay, this is the image. So you can see that this is very large. So what we can do this is resize this image. Okay. So width we need to variables in height. So our original image is 1200 by 1600. So like, let's bring that number down to let's say, yeah, let's make it to 400 by 600. Let's display another variable. You can also change the original image. So there is another function called cv2 dot. So if you want like to find out what are all the functions, you can just type cv2 dot, and these are all the functions you can use. Okay. And I'll be using this function resize. So first it will take the input image, then the required size. The required size is width by height. Okay, then let's display this. Yeah. So this is now much more smaller. Okay. So this for resizing. Now let's move on to converting the color. So if you want to convert from colored image to grayscale, then you can, there's a built-in function image gray. So I'll be converting it from RGB to gray. CV2 dot convert color input image, and then there's a code for converting the color. So this is the code: blue, green, red to gray. Okay. So the OpenCV follows the convention. It follows BGR instead of RGB. Okay. So I have converted this. Now yes, let's use this here. Now it's gray. Similarly, you can also, if you have a grayscale image, you can also convert it back to colored. Now let's move on to cropping the image. So for this, you need to know how to slice an array. Okay. So in NumPy, you can crop the array. You can slice the array like this. So for this image, for this array, the first element is height, then width, then number of channels. Okay. So if you want to crop this image, prepare a variable again, and we want to crop it vertically. Okay. So we want to crop it from the top. So we have to provide a range. Well, there are three parameters. So we have to give it a range. So like for example, A to B. So I am giving it from 0. You don't have to write 0. You can just leave it like that. 0 to 300 pixels. Okay, so it will crop till 300 pixels vertically, and then let's just leave the width as it is and the channels. You can see this image is cropped. You can also crop its width. Example. Now it's also cropped vertically and horizontally. So that's basically how you can crop these images. Moving on, let's sometimes for processing the images we have to blur the images to reduce some noise. So there's a built-in function for this also called cv2.gaussian blur. There are different types of blurring techniques. Most common one is this. There are also median blur. It's not showing here, but there are different techniques basically for blurring the image. They follow different algorithms. Let's input the image, and then we have to input the kernel size. This k size is kernel size. This is a filter that will be superimposed on your image, and the bigger that filter is, the more blur will be the image. Okay, and it is generally odd number, so 3 by 3 or 5 by 5. Okay, like that. So if you do it one by one, then it will just not do anything. Let's do it 5 by 5. And the sigma x, you can leave it for now. Let's put it 1. This parameter is not that important. The first two parameters are that you will be dealing with most of the time. Okay, let's display this. This is blurred. This is now blurred. If you want to compare with the original, image 1, original image. So this is normal original image and this is blurred image. So this is quite important function. It comes in handy. So yeah, that was some basic functions that you will need. That you will be needing further. So yeah, you can ask we will take all the doubts at the end of the session, and we will also be providing all the code, so don't worry. So I request now Mang to continue with the doc scanner part.
Thank you, Shantanu. So now let's start the final the project which all of you are here for. So I hope my screen is visible.
Yeah.
So we'll start as Shantanu started with importing. Yeah, in this, if you wish to use a webcam, then you can use we'll define a variable cap, and you can use the cv2 function video capture. In this, you can set your port. In my case, it is 0, so I'll set 0, and then you can set parameters for this as cap set. 10th is the brightness, so I'll be increasing the brightness in this case. Or if you wish to edit height or width of your camera, you can do it using these functions. As you can see, these are the parameters for cap set. The fourth parameter is height. 0, 1, 2, 3, 4. The third is height, fourth is width, then frame rates. These are all the parameters. Brightness is on the 10th. You can set the contrast, saturation, etc. Yeah. Now for displaying the camera, since a video feed is basically images, it's images that is continuously updating images. So we'll use a loop. and I'll display the I'll loop it while true, and I'll set the variable as cap read as image, and I'll display the image using the function I am show. Okay, so if you see this code, where is my window? Okay, here it is. So you can see that I have got the video feed. Well, in this example, I'll not be using my camera feed, so I'll be using the image that you just saw. So we'll just comment the camera feed, and we'll be using the image file. So this is the image file that we'll be using for our demo session for the project, right? So now for starting our processing, we'll first pre-process the image. So for pre-processing, we'll start it by converting into Grayscale. As working with Grayscale is like you actually eliminate it, you actually have a 2D image, so it's much easier. So you'll convert, use the function CVT color. You will give the source image. Then we'll be converting into Grayscale. So we'll be using BRG convention color BRG gray. This will convert the image to Grayscale. And to reduce the noise, we also have to add blur. We'll add blur to this image. Let's add Gaussian blur. We'll add Gaussian blur to the gray image. As we have grayscale image, so we'll add the Gaussian blur to this gray image. Now Shantanu just has explained what these parameters are, so I won't. Okay, now that we have a blur image, now we can actually apply the canny detector for edge detection. So we'll take another variable and we'll add canny on this. Now in this function, we'll first provide the source image. So we are using the blur image in this case. And then we have to define the threshold. So for this threshold, let's say I'm writing 200. Okay, so in this threshold, I'll actually see, you need to actually adjust the threshold according to your image. So if let's say I write it 200, or let's say example write it 0, and then return image canny. And if we actually display this image, I will show canny image. Leave pre-processing image. If you actually see this image, you are in this case, see, you are getting these noise. There's no edges over here, but still we are getting this noise. So to remove this noise, we actually have to adjust these parameters. So to adjust these parameters, a track bar is usually helpful, so that we can actually see real time what we are changing. So in this, I will just add a threshold. Let's start over here first. So we'll first make track bars. In this, I'll initialize a track bar with initial value 0. You have to make a window, name track bar. Then I've resized the window over here. Then we actually create a track bar using the create track bar function. Give the name of the track bar. I've given it threshold 1 over here. And then you mention the window in which you want that track bar to be present. So I want that track bar to be displayed in the track bar window. So I have mentioned it here. Now I have given the starting value 80. Let's do it 0. Yeah, and I want the max value as 255. as the function, this function takes highest value is 255. And then the fifth argument in this function is actually you actually have to give a function over here which actually updates every time the value changes. But in our case, we are not using that method to get the values. So I'll just define empty and define an empty function over here. I won't be utilizing this for getting the values. Similarly, I have created a second track bar over here. Now for getting the values from this track bar, I have defined a function value track bars. In this, I am defining variable threshold1, and I am getting the track bar position using the get track bar pose. From that, I am getting the threshold1 value in the track bar window and threshold2 value in the track bar window. I have defined the value. Again, I am returning that values. In my now I have returned the threshold1, threshold2 in value track bar. So I'll be calling that function over here, value track bar, and I want the 0th element in the first place, value track bar, the first element in the second one. Now if I also have to initialize the track bar first. So now if I run the window, you can see that I have a track bar, and as I move it, you can see I am actually reducing the noise that actually I'm getting. So you can use this track bar to actually adjust your values to your optimal conditions, like whatever, like you'll be having a different background, a different quality, so you have to adjust it accordingly. Okay, now in this example, you can see the lines are very thin. So let's dilute these lines a bit. So we'll dilate these lines. So I'll be using the function image. I'll use image dilate, and I'll be using the function dilate. In this, I'll be giving the source image, that is canny. And in this, we need to define a kernel. So I'll just make a variable over here, kernel. And let's define a kernel over here. Now kernel is an array. So let's define an array of ones. So I'm making a numpy array of ones. Dimension, let's say 5,5. Yeah, and let's perform 2 iterations on this and return dilate image. Now if I run this code, see, now you can see, now actually I have dilated a bit, but much more. So you can see I've actually merged all these lines. So let's erode this function. So eroding basically removes the dilation. So let's image as threshold image. So this will be my final image. I'll be using erode function. Let's give the dilated image as the source. As the kernel, I'll be using the same kernel. And I'll give 1 iteration in this case. Let's change this to threshold. So now you can see I have a better line in this case. So let's adjust it. And around 75, I am getting a perfect rectangle. So I have detected my edge correctly. Now that I have detected the edge correctly, okay. So now let's go to contours. So contours, now that I've detected the edge, let's get those values of that edge. So we'll make a function contours. Hierarchy. This we'll say cv2 dot find contours. In this we'll give the image. We are taking the argument as image, so I'll provide the same image over here. And I need the biggest contour, like the biggest rectangle. So for that I'll be using the external function, and I need all the contours, so I'll be avoiding any chain approximation. So I'll get all the contours. Now let's make a loop which I can actually see the contours. In this, let's say, 1 second. Now in this, we have many contours. You can see, like I have this pen. Like this pen also I have been detected as a contour. Now I don't need these contour. I just need this main rectangle. So for that I'll define an area that I only need. So we'll find the area of this contour using contour area. Yes. Now let's see if the area is actually greater than 500. Only then it will say that only then it will give me the output as a contour, otherwise it will not. So the noise and all that can be removed due to this. Okay, now let's calculate the parameter, and actually now we need to find the rectangle. So for that, let's find the parameter of that and give it the corner points, and when there are 4 corner points detected, we can say that it is a rectangle. So I can take that output. Yeah, so we'll calculate the length. So that arc length is used. We need the length from the contours, and I need a closed loop, so I'll keep it as true. Yeah. Then I'll be naming the function as approx, and this is for corner points. So for this, for corner points, we'll be using approx from polygon pp. Okay. In this I'll be giving the contours, and this is the value that actually gives me the exact corners. So I'll be using this 2.2 into perimeter. This actually gives me a good result, so I'll be using this, and I'll be keeping this as true as I need a closed loop. Now let's define the area is greater than max area, as there are many areas, so I need the maximum area, and also I need the lengths of the approx to be 4. I need the approx length to be 4. So 4 means that I have got 4 points, so I'll be taking that. Now that value I'll be defining a variable biggest, and I'll be inputting that value. So I'll give that value approx, and I have to run this loop for each area I find. So I'll be saying max area is actually equal to area. So each time this loop iterates, it will get the next size loop. So let's now define what is actually biggest. Biggest is actually an array. I'll just make it an array, and max area, let's start with 0. Okay, so I now have the points, so let's actually see what I get by printing those points. and I'll return biggest. Okay, biggest as pre-processing, and I'll give the source image for pre-processing to get the points as biggest. Now if I run this code, see now I'm not getting any contours as this I'm getting noise over here, so I'll adjust this threshold. Okay, why is it not giving me the points? Oh, sorry. I wrote it as pre-processing. This has to be to get contours. Okay, so it is actually not detecting any contours and it is exiting. So let me just change this value to 75. Just a second. I have defined max area over here. No supported combination format. Why is it saying this? I've used the correct one. Which can you not define? Okay. I actually forgot to define that image first. Which can be equal to the processing image. Image over here. Now let's send that image to pre-processing. Max area I have defined. Okay, now you can see I'm getting the points. If you can see, I am getting 4 points. 1, 2, 3, 4. These are the 4 points, the edges that it is detecting. Now let's see if I can draw these in the image also. So I will be using cv2 dot draw contours. Let's say, for example, I will be making a new image of contours. I'll just define this image. I'll make a copy over here first. I'll make an image contour. Here, and I'll copy this original image. So I'll be using img.copy to copy this original image. Now in this contour, I need the biggest point to be displayed. So the biggest is actually those 4 points that we are getting, and I need all those points to be displayed. So -1, and let's say I need it in red, so I'll give 0, 0, 255. As you know, it is BRGB. No, it's BGR. So R is 255. And let's give the thickness as 10. And I will be needing this image. I'll just say cv2 dot IM show, and I need, let's name the window contours. Let's see. Okay, I forgot a comma over here. Now see, I'm getting the 4 edge points of this image. Now similarly, if you actually want to see the edge also, you can just use the same function over here, and let's display the contours, that is actually the edge that the computer is actually perceiving. Let's see that also. So see, this is the edge that it is actually seeing, and it is marking the biggest contour it is detecting, and marking the 4 corner points of this contour. So actually we have corner points. Let's decrease the thickness. So I got the image contours, I got the corner points. Now let's now our next step is to change the perspective. And this you can see that it's a tilted image and I don't need all this side. So I want to warp this perspective. So I'll be making this function warp perspective. In this I'll be giving points. I'll be defining point 1. Point 1 is actually my image point that I'm getting. So 32 biggest. Yeah, my second point is actually the point that I want, so that will be 32, and I need the point as 0,0. As you know, the convention in this OpenCV is that this is 0,0 and this is the x-axis. So this is 0,0 and this is the highest value, and similarly this is the y-axis. So 0,0 and the y-axis. So I'll be defining 0,0. Then I want the width, comma 0, and I have taken the W capital. So I need the width. Then I next need 0, height, and 0, height, and the last point will be width, right. So in this you can see this. In this is actually 0,0. This is the width. And so this will be width on 0,0. This point will be our 0 and height, and this will be width and height. So I need these points, these 4 points, to actually warp into these points. So I want this point over here, this point over here, this point over here, this point over here. So now let's do that. So I need a matrix. For that perspective change, I will be writing a matrix. C2 dot get perspective transform. I need to transform that. So I need from point 1. So I need go to point 2. And I want the image output. Image output to be CV2 warp perspective. Image matrix transform and my height width of that final output image. So I'll give the same height and width. Okay. Let's return image output. go here. So let's return this in the output. So I have now image warp, and I want to use get warp. Now for warping I need the original image, and I will be giving him the points. The points is the biggest. Now let's say cv2 dot im show warp image and image warp. Now let's see. Okay, so now you can see I'm actually getting the wrong warped image. What I'm actually getting is these 2 points have, like, this point has gone here, this point has gone over here, and I'm getting an empty space. So this is not what I wanted. So I actually want these points to be in order. Every time you run these code, these points can be in different order. Like this can be 1, 2, 3, 4, or 1, 2, 3, 4. So I actually need them to be in the order that I actually want. That I want them so that I can warp it correctly. So for that I will be reordering these points. One more thing, if I actually don't get any points, this code will give me an error because it's trying to warp, but there are no points. So what will be it warp? So what will be it change? So I'll get an error. So to correct this error also, I'm going to show you a if statement, so that actually you can get your feed and then adjust the track bar to get the correct values so that you can detect the contour. So for that also, let's first reorder the points. So okay, so for reordering the points, you can see 0, 0 is over here, width height is over here, 0 height and width height. So if I actually add these numbers, let's say 0 plus 0, width plus 0, 0 plus height, width plus height. So the smallest value I'll be getting will be 0 plus 0, and the highest value I'll be getting will be width plus height. So let's apply that logic and change those points. So I'll be giving the variable my points, and first I need to actually reshape those points, as in this. Okay, that example is gone. Let's run it again and get those points first. Let's see if I got it. Okay. So I'm getting those points. So in this you can see the shape of this array is actually 4, 1, 2. So I won't be able to add, like I have 4 values, I have 4 points, and I have two values x and y. So I only need 4, 2 array. So I'll first reshape this array. So let's reshape. So I'll reshape into 4, 2, and the final output, the final points that I need are actually need to be in 4, 1, 2 shape. So I'll define a new array. That array, let's initially put the values as zeros, and the shape I want is 4, 1, 2. This is the shape that actually when I'll put in the function, that will give me a correct output. So I wanted an integer 32. Okay, so let's now add the points. If I add the points, and now let's give the new points. So I'll give the 0, 0 will be the smallest one. So I'll just say from my points, take the least argument min from add. And similarly, I want the width and height will be actually the highest one. So I want the max one to be the width and height. Okay, so I got 2 points correctly. Now I need the width and height to be correct one. So in this case, if I subtract these values, just like I added these, I'll subtract these. So in subtracting, I'll get the 0 0. In width and height, I'll be getting width as a positive, and in height, I'll be getting a negative value, and width and height, though I'll be getting some value. I don't need that, but that value will be lower than width and height. So if I subtract that and I get the min argument and max argument, I can easily distinguish width and height these points. So for that, let's actually do the difference. So let's subtract them. Now I've subtracted, so I'll be taking the new points as my points. Will be argument min some difference, which similarly for point 2 I'll be taking the max point for the second one. Okay, now this I'll return the value, my new points. If I got the new points, now in this, okay, let's also print and see the new points. My points here. Let's see. Okay. Let me actually get the. And also let's solve that problem that I was getting earlier, that if I don't have the value set of the track bar, I won't be getting any error. So I won't be getting any edge. So this will give me an error. So let's also solve that problem. So for solving that, I simply need to say that if there is something in biggest, if there is actually anything in biggest, so I'll say if biggest is not equal to 0, then only the biggest is equal to reorder biggest. Then only it will reorder the function, or else it will just return zero. Okay. So now, okay, so let's first see this. So see, it is returning nothing and I'm getting a blank window. This is actually the window I'm getting. This is a blank window. Okay, and I'm getting a blank array over a 0, nothing. Now let's see the points. Now I'm getting the contours, and you see in this code, I'm also getting the points. This was the order earlier, and this is the new order that I'm getting. Right? Okay, I forgot to show you the warp perspective. So this is the warp perspective that I'm getting. Using these contours, I have warped it into a, like something what you see on your Adobe Scan or Cam Scanner. That is your warp perspective, image cropped and all. Okay, so I was getting a blank window. So instead of getting a blank window, let's say it gives me a blank image. So for that, I'll just say that Like earlier in that code, I wrote that it should not run that function. So same thing I'll be doing over here. I'll say biggest size is not equal to 0. Then only give me the image, else display me a black image. So for a blank image, I'll just create a numpy array that is of zeros. Therefore, a zero array is actually a blank image, so I'm getting a blank image over here. Let's give it a name warp. I want nothing in this, so I'll be saying I want the zeros of height and width. And let's add the third dimension also, the 3 channels. And I want it to be 8-bit image. So now you can see. What happened? Okay. Is it giving me a syntax? So now it is giving me a blank image. If there is nothing detected, it will give me a blank image. And let's say if there's something detected, I'll get that image. Okay. These are giving me extra windows. I'll just close them. Each time I'm getting multiple windows, so I don't need that. Okay, so I'm getting the warp image. I've done the reordering. I've got the contour, data processing. Okay, now let's apply some scan effect. Like you want a black and white scan. So this is actually nothing. You're just cropping and getting the image, but you want it to be more clear. Like all these text and all. Like this has to be black and white scan. Let's say. So for converting that. Okay, before that, let's also crop this image a bit, because if you see over here, I'm still getting an edge. This is a curved sheet, no? So I'm still getting an edge. So I'll just crop it from each side. I'll just crop this image. So let's say image cropped. I want the warped image to be cropped. So I'll be giving the warped image, and let's say I need 10 pixels removed from each side. So I'll be just removing 10 pixels. So I've removed 10 pixels from each side. And let's display this cropped image instead. Let's get the edge. Now I'm getting a more cleaner image, cropping it. Okay. Now let's add some adaptive threshold that will actually give it a so now let's convert it to grayscale first. We don't CVT color. I want the cropped image. We turn it to grayscale. I need the color from VRGB to gray. Now that I have the gray image, I'll be, let's say, adaptive threshold. So I'll be giving it a scan field. Let's name it adaptive threshold and CV2. adaptive threshold, and I want the bobbed gray image. Okay, I want the warped gray image. These are some parameters that I actually use it and try and work them. So this is the one that actually let's see. Now let's see the image that I'm getting from adaptive threshold. So I'll give it the name which says scan. I'll name the window scan. Give the adaptive threshold image. Okay, I'm getting it in black and white. Oh, I forgot to convert that. Like I actually need to turn the black pixel into white and white into black, right? So I'll use a bitwise operator, bitwise not. Okay, and I need to actually reverse the zeros and one basically. So I'll give the image over here. That will reverse the effect. So I'll get that scanned copy in light mode. Instead of dark mode, I'll get it in light mode. So now I have the scanned image and I have the warped image. Now in this you can see that actually the image quality is not so good. That is why there are some errors still. Like you can see this is not clear, but it is readable, it is legible. This is now let's say if we can save this image as well. So for saving this, let's say I want to save this, so I'll give ev2.cv2.image write. Write function is used for actually saving the images. So I want saved as scanned image plus I'm naming the file. So let's say in this I want that each time I save it increase the counter, and I want it in format of JPEG, and the image that I want is image cropped. Okay, I'm saving the scanned image, so I'll take the adaptive threshold image. So cv2 dot I am right. Let's say I'll say it as colored image. Yeah, let's add the counter in this also. .jpeg, and in this I'll save the cropped image. So I'll get both the images, the colored one and the black and white one. I'll get both those images. cv2 dot bit key delay, maybe 300 milliseconds. And I want count, and each time I save the image I don't want it to overwrite the image, so I'll increase the counter, and let us define the count over here, count equal to 0. Now if I run this code, I'll adjust these values. Okay, I got it in one try. Okay, now I've got these two images. Now in this I have actually set the key as S, so each time I press S it will actually save the image, and it is 300 milliseconds, so it actually exited the code. Now if I actually show you, I got the scanned image saved over here. In my directory you can see this colored image and the scanned image. I have them both saved over here. That was all the code. Any doubts?
Yeah, if anyone has any doubts, can ask now. You will also link your GitHub.
Yeah, I'll just share that GitHub
Yeah.
repository. This is the code. In this, you will also find the image that I've used.
So I guess that's it.
Okay.
Thank you, everyone. We'll be back probably later, some like 2 or 3 weeks later, with another workshop in the same OpenCV series. So stay tuned for that.
Hello,
Thank you, everyone, for attending. Bye bye.
hello.
Yeah.
Yeah, I have a doubt. Sorry
Thank
for
you.
sorry for replying late, but I have a
Yeah.
doubt.
Of course.
Yeah, so I was seeing the code of it, and I was really it was quite nice. And I was listening about the basics also. So right now I'm not having any active Python software on my computer like PyCharm and all. So I was
Yeah.
doing it on REPL.it.
Okay.
So I took an image and I took an image name and tried to paste it there with the whole address also, but it is showing me an error when I perform some actions on it or processes on it.
Yeah. Actually, OpenCV, like, you cannot do it in online editors because it's creating like all the windows and sort of stuff, right? So I think OpenCV doesn't work in online editors. I have tried that myself. So you have to do it in your local machine. Yeah,
Okay, okay, okay. Great, thanks.
no problem.